Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Hidayah binti Husni, and I will speak about mechanical properties and microstructure of pre-dry and undry PLA filament in additive manufacturing. Now we move to the research background. FDM is one of the 3D printing technique that was widely used in industry. FDM creates 3D structure by extruding preheated thermoplastic filaments at predetermined process parameter. Humidity is one of the factors that will contribute to the 3D printed quality. Humidity filaments will interrupt the extrusion of the filaments during the FDM process. This is because the mass flow rate and humidity are correlated. PLA filaments are known for their hygroscopic characteristic, which is absorb moisturizer. The filaments that has absorbed the water will expand, boil and break as the filaments extruded. This can affect the surface quality, adhesion rate, and mechanical properties of 3D printed spark. By pre-drying the moisturizer exposed filaments, it will eliminate the moisturizer, which avoid the printing instruction as well as produce high quality of 3D printed spark. Therefore, in this research, our aim is to analyze the mechanical properties and microstructure of the pre-dry filaments compared to the undry filaments. For the methodology, 3 conditions were established in this research. So the first condition is new filament as the reference. Second condition is use filament stored in vacuum bag with 50 gram desiccants, and the third condition is use filament stored in an open environment and exposed to the humidifier for 48 hours, 96 hours, and 150 hours. Then 3 groups were created from the condition mentioned above, such as for the first one is undry sample, the second one is pre-dry sample by using dehydrator, the third one is pre-dry sample by using oven. Next, as can be seen in Table 1, Table 1 shows the setting of the pre-drying and process parameter for 3D printer, which were constant and applied to all groups. So as can be seen in Table 1, the parameter for drying methods are the filaments will be drying at the temperature 50 degrees Celsius for 6 hours, and for the 3D printing parameter, the printing temperature that we have set is 220 degrees Celsius, and the bed temperature is 60 degrees Celsius, and printing speed is 60 mm per second. As can be seen in Figure 1 until Figure 1, Figure 2, and Figure 3, it shown the oven, dehydrator, and the 3D printing that has been used in this research. Now let's see the testing and analysis method that employed in this research. Shimazu AGS UTM machines are used for mechanical testing. So mechanical testing that has been done in this research is tensile testing and flexural testing. Next is for the microstructure analysis. For this analysis, fracture tensile specimen was adopted and analyzed by using the scanning electron microscope machine to observe the void and adhesion on the sample. For porosity analysis, decimeters are used to measure the density of the specimen and validate the porosity in the specimen. Now let's see the result and discussion of this research. So Figure 9 and 10 illustrate the tensile and flexural maximum force for all conditions. The highest strength was observed in the reference sample for all groups. Among all the conditions, the specimen humidified for 150 hours was recorded the lowest tensile strength and fracture strength. When the filaments is humidified, the tensile and flexural strength decrease due to the propagation of crack in the filaments. Pre-drying the filaments with both dehydrator and oven increase the maximum force and reduce the fracture strength. Now let's see on Figure 11. Figure 11 depicts a tensile stress and strain graph for reference filaments. Based on the graph, we can see that the pre-drying filament shows a lower strain hardening than the undry filaments, as the failure strain increases when the polymer absorbs the humidity. Now let's see on the density result. Based on Figure 12, it can see that the density decreases when the filament is exposed to humidity. The density for undry specimens is lower than the density of pre-dry specimen for both drying methods. So the density measurement validates the tensile and flexural strength, showing that the drying process has successfully reduced the water absorbance, creating a denser 3D printed parts, resulting in a better mechanical strength. Now let's see the microstructure result. Figure 13 depicts the same image for reference filaments compared with the humidified 150 hours filaments. The cross-sectional tensile fracture surface of the reference shows a fewer voids, good interlayer additions, and shorter interlayer gaps compared to the longer humidified filaments for both undry and pre-dry sample. So a good interlayer addition and short interlayer gap result in higher tensile strength than a weak interlayer addition and longer interlayer gap. Now let's see the percentage improvement in the pre-dry filaments compared to the undry filaments. So based on the table 3, it can be seen that the pre-dry using dehydrator significantly shows the most improvement compared to the pre-dry using oven sample. It also can be seen that the specimen with high porosity and low density has the lower mechanical strength due to the crack propagation that happened in the filaments. As a conclusion, the presence of the moisturizer in the filaments will reduce the mechanical properties and increase the porosity. The outcome of this research has shown that the pre-dry filament sample will produce a better 3D printed part with a highest mechanical properties, high density, and good interlayer bonding in the microstructure. The originality of this research is pre-dry filaments is not studied by any researcher, and this idea actually can reduce the waste of the filaments and promote the sustainability if the used filaments and the exposed filaments can finally adjusted and improve the 3D printing. So by the recent work that has been done, it has proved the hypothesis, and this message can be delivered to all the 3D printer user.